This information is brought to you by Charles Sturt University.
Hi, this is a short video for Maths 218, multivariate calculus. This is from tutorial 5, question 2d. So this is another question on how to work out a double integral. So this one's a little different to some of the previous questions in say question 1 of the tutorial, where you're not given the limits, you have to work them out yourself. And so it actually describes a region geometrically. So I think a good idea is to draw a picture. So we've got a region bounded by a different curve. So y equals 0 is the x-axis. We've got x equals 1, which is a vertical line going straight up. Well, sort of. If my picture was better, it would be going straight up. And the line y equals x squared, which cuts at some point in time. And again, you can work it out. So when x equals 1, plug in 1 squared, it gives you y equals 1. And we want to work out the region which is bounded by those three curves, which would give this sort of region here. So what I want to do is I want to integrate over this area. So we can consider this region in two different ways. We can either consider it vertically or horizontally. Now, since we have the top curve as y equals x squared and the bottom curve y equals 0, it sort of makes sense to do it vertically, just because that's sort of how things are more naturally written down. You could also consider it horizontally, so going left and right, and you consider the leftmost curve, which would be x equals the square root of y, and the rightmost curve, which would be x equals 1. And you can do the limit of x first if you wanted to. Because we've got cos y, which is easy to integrate as it is, let's just try that one first. So that's the natural way the questions are asked, so let's try this way. So therefore, we can see that we've got our integral of cos y, and since we're integrating vertically, we're integrating respect to y first and then x second. And the integral for y is between 0 and x squared. Then we have to specify the limits for x. So the smallest x gets is 0, biggest it gets is 1. So now we've put some limits down, we can just do a normal iterated integral. That means do the inside bit first. So the framework for the outside just stays there. X is neither here nor there, so just going to leave it. So integral of cos y is positive sine y. And you're between 0 and x squared. And you can see I can factor since we're just doing something y's here, I can leave x's at the front. If I set if y equals x squared, I get sine x squared. If I let y equals 0, I get 0, so I just won't bother writing it down. Now he's going to try to integrate this term. Now you can do it by observation, and so what I'm often tempted to write down is to go the derivative of the inside is 2x, and you sort of write down the answer. You can do it by substitution, so how do I do that this exercise? So I'll let u be the inside, so I've got a function here. So I use sine x squared, so let u be the inside. So take the derivative. So du dx is, say, 2x. And du is 2x dx. Now I can see a x dx floating around, so I'll just divide both sides by 2. So I can replace the x dx all in one go. So there's an x, dx that I can see. So I'm going to replace that all that in one go in a second. Before I do that, I also need to replace the limits. So x is 1 and x equals 0 are the limits. So substitute those in our expression for u. So x equals 1 gives me u equals 1 squared, x equals 0, u equals 0 squared. So now our integral, let's call it I, is now the limit. Well, we are changed from x equals 0, x equals 1 to u equals 0, u equals 1 of, well, x sine x, that's the bit that's in yellow highlight, now becomes du on 2. The sine, well, it sticks around, and the x squared just becomes u. And now we can integrate easily. So the half just sticks around. Integral of sine becomes minus cos. And again, it's, I don't know about you, but at least for me, I just have to be really careful about getting the signs right integrating. I just double check by differentiating. So derivative of minus cos is, yep, positive sine, yep, works. So now we just need to work out sub the limits from 0 to 1. So minus half, I can just keep out the front. Sub in 1, I get cos of 1. Sub in 0, I get cos of 0, which happens to equal 1. Maybe get rid of the minus sign, so that's maybe equal to 1 minus cos of 1 all over 2. Whatever that number is. And therefore that's the end of that's the answer to the question. And you could answer it numerically if you ever needed to for a certain application in mind. So I hope that helps. So just reiterating, when faced with a double integral where the region is given by certain bounds, draw a picture. It will certainly help you a long way. Once you've done it, work out the bounding curves, either vertically, so work out the top and bottom curves, or you can do it horizontally, work out the most left and the most right curves. That also is fine. Some work one way might work much better than the other. And then once you do that, you can then write down the limits and then just do it as an iterated integral. So that's a good process to try to tackle many times. Hope that helps.